Okay, so this is where I also explain what characteristic curves are. Okay, so find the solution to the ODE. This we've already learned that we can write this. This is the coordinate of x and this is the coordinate of y, right? So we can write this as x squared, comma y. Okay, then nabla of u equal to 0. So in u we have x and in u we have y. So the change in u with respect to the change in y, the gradient, because nabla is the gradient, so we can just say the gradient of u, okay, is just the rise, which is y over x squared. Okay, so we see that this is separable. So we can write this as 1 over y dx dy is equal to 1 over x squared, which can be written as x to the negative 2 dx. Okay, just to simplify things. So now what is, we integrate this and this, so this side we're going to have natural log of y equal to this side integrating, so we say plus 1 and over 1, so this will give us negative x to the negative 1 plus c. Okay, then we can write this as, this is log to base e, so it's the same thing as y is equals to e raised to the negative x to the negative 1 plus c. Okay, we simplify the constant, so this can be written as y is equals to c e to the 1 over x, negative 1 over
x plus, okay, yes.
Yeah, so we can write it as this. Now
I lost it here.
Yeah, so when you just see the power that is more than 1, you just raise it to the negative 2, to the negative that power, then you do the integration. Now they ask you for characteristic curves. So when they ask you for characteristic curves that have the slope, dy dx equal to, our dy dx is equals to y over x squared. What they're just asking you is make c subject of the formula in this equation. Okay, so making c subject of the formula, so first of all we have y equals to c e to the negative 1 over x. What do you think we can do to make c subject?
Do we divide by that?
Yeah, so we divide it by that, or we can just say times e to the 1 over x, even this side times e to the 1 over x, so that these powers will add and we're going to have e to the 0, and simply you're going to have c being equal to e to the 1 over x y. So now the characteristic curves will be written as, so you write this equal to e to the, okay, I'll start with y e to the 1 over x. Then now you write another function, okay?
Yeah.
You write u of x comma y will be equals to a function of this, okay?
Yeah.
And this is simply equal to the function of y e to the 1 over x. So this would be the characteristic curves. So And that's all. So when they ask for the characteristic curves that describe that, it will be this. Okay. For a simpler equation, suppose you might also be asked to sketch this one. Okay, not very friendly, but you might also be asked to sketch the characteristic curves. I'll give an example of a simple one. Suppose you have 1, 2 nabla of u equals to 0. You know that the gradient, okay, the gradient, okay, let me put 3 here, okay, so that you see properly. The gradient, what would be the gradient here?
2 over 3.
Yeah, 2 over 3. So we see the gradient is positive, right? So the characteristic lines would be this positive. Just this, drawing a positive line, you know that this is positive, right? And if we had -3, 2, meaning that our gradient dy dx will be equals to negative, so 2 over 3. So negative gradient is described by this type of characteristic curves.
When you're plotting, do these lines for the positive, do they have to